Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And remember, it's easy level according to the, you know, pretty smart variant Sudoku solvers on Logic Masters Germany. So take that with a grain of salt. And it's called On a Knife's Edge by Sudoku. And here are the rules. Normal Sudoku rules apply. That is, each row, each column, and 3 by 3 region has to contain the digits from 1 to 9 once each. On both main diagonals, digits do not repeat. So again, uh, in addition to the normal Sudoku rules, you have additional 1 through 9 set on each diagonal. Because that's the consequence of essentially digits not repeating on a diagonal, right? You have to have 9 unique digits, and therefore 1 through 9 has to be on each diagonal specifically. Digits on an arrow sum to the digit in the circle from which the arrow emerges. So these are called arrow rules. So this digit must be the sum of these 3 digits. And same thing for all the other arrows. Digits in a cage sum to the clue in the top left. So for example, these 3 digits must add up to 16, these 3 must add up to 13, these 3 must add up to 15, and these 3 must add up to 12. And those are called killer cages normally. Digits on a marked diagonal sum to the little killer clue outside the grid. So I'm not sure why this has always been called little killer, but that's what these are, little killer clues. And these 2 digits must add up to 10. These 2 must add up to 11. These 2 must add up to 9. And these 2 must add up to 17. That's a little killer clue. And a digit in a gray circle must be odd. That's it. And those are the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, simple one that we know. These 2 add up to 17, which means this is an 8 and 9 because that's the only possibility for 2 digits adding up to 17, essentially. These 4 circles have to be 6 through 9 because they each contain 3 unique digits. And 3 unique digits can only add up to 6 through 9 if it's a single digit. If it adds up to a single digit. So this is 6, 7, 8, and this is not 6, 7, 8, 9. This is 1 through 6. This is 1 through 6. Well, actually, let's not do that one right now. This is 1 through 6. This is 1 through 6. So this has to be 6 through 9. This is 6 through 9. This is 6 through 9. And this is 6 through 9. Now, the thing is about the diagonals being unique is that each of these 4 cells in the corners sees the other 3. Right? This sees it because this sees these 2 because of Sudoku rules. And this sees this one because of a diagonal. Must be unique. So, and this is the same for all 4 of the different digits. So therefore, all 4 of these digits are different. So we're going to make that green. We're going to make this red. We're going to make this blue. And we're going to make this orange. Now, we know these 2 add up to 17, and therefore is an 8-9 pair, which eliminates 8 and 9 from box 3, from all the other cells in box 3. Therefore, this cannot be 8 or 9. That's why I didn't fill this in as 1 through 6. This has to be either 1, 2, 3 or 1, 2, 4. And we know the 1 and 2 have to be there. So this is 6 or 7. This cannot be 6, 7, 8, or 9 because it sees all 4 unique numbers from 6 through 9. So this has to be 1 through 5. So this is 16, which adds up to, which cannot contain a 1 or a 2. So it must contain a 3, a 4. It's 16, right? If you cannot have a 3 or a 4, the minimum would be 5 plus 6 plus 7, which would be 18, which is not possible. Therefore, we know the 3 or the 4 has to be here. So it's either... So 16 with 3 could be 3. It can't be 3 and 4 because this one of these two has to have a 3 or a 4. So at least it's 3, 5, 3, 5, 8, or 3, 6, 7. So it could be 3, 5, 8, or 3, 6, 7. Or it could be 4. So 4 and 5, 4, 5, 7. It would have to be 4, 5, 7 here if that's the case. So in box 6 now, we know we have it take into account 1, 2, 3, and 4. So the rest have to be 5 through 9. Right? So if this is 1, 2, 4, this could be 3, 5, 8, or 3, 6, 7. And if this is 1, 2, 4, this has to be 4, 5, and 7 specifically. Okay. 12. So this can never be... Okay, so anytime you have three digits, unique digits that add up to 6 through 9, you always have 2 digits in the set of 3 that are 1 through 3. Right? The most you can have is 1, 2, 6. Okay, try to have it with only 1 that's from 1 through 3. If you have 1 from 1 through 3, the minimum of that would be 1 plus 4 plus 5, which would have to add up to 10. Therefore, we always know that in 3, I guess this is a kind of a useful shortcut. If you have 3 cells that add up to 3 unique cells, I should say, that add up to another digit, you always have to have 2 out of 1, 2, or 3 in those 3 unique cells. Therefore, we know this one, and if for 3 cells that add up to 12, you also have to have 1 digit that adds up from 1 through 3, right? The minimum, try without it, right? The minimum, if you try to add up 3 unique digits to make 12, or 3 unique digits in general, without a 1, 2, or 3, that would have to be 4, 5, and 6. And the 4, 5, and 6 added up together is 15. Therefore, this has to have a 1, 2, or 3, which means there are 2 digits from 1, 2, or 3 here. There's 1 digit from 1, 2, or 3 here, which means none of the other digits can contain a 1, 2, or 3 in box 8. So this is 4 through 9. This could be 1, 4, and 7? I don't think it can be 1, 4. If it's 1 and 4, this would be 2, 3, and 5, and that doesn't work. So this cannot be 1 and 4. Therefore, this is also 1 through 6. Right? So this has to be 7, 8, and 9. Because so it has to have 1 from 1, 2, or 3. In addition to that, if you try to make it 1, 4, 7, which is the maximum value you can have in this set of 3, in this 3 set, then this would have to be 2, 3, and 5 left over, which would add up to 10, which is not possible. So this can never have a 7 in it or above. Therefore, it must contain 3 digits from 1 through 6. And if that's the case, then we have 6 digits in box 8, which are from 1 through 6. So therefore, those unique digits have to be in those cells. And they cannot be in any other cell in box 8. So therefore, this has to be 7, 8, 9. Now, for this to be 6, I guess it could be 2. 2, 4, 6. 2, 4, 6, 1, 3, 5. Right. Can this ever be not a 9? This Okay, actually, hold up. We know this box equals 45. These three cells added together add up to 24. So that means these 6 cells equals 45 minus 24, which is 21. We know these 3 cells add up to 12. So these 3 cells must add up to 21 minus 12, which is 9. Therefore, we know this is 9. So this can't be 9, this can't be 9, this can't be 9 anymore. Because of that, we can eliminate 6 as a possibility here, and 6 as a possibility here, because the only possibility for 3 unique digits with a 6, it would have to add up to 9, and neither of these can add up to 9 anymore. So this can't be 9 either. This has to be a 9, which means the 9 is over here. So this is either 126, 135, or 234. It still can be any of these. The 1 also has to be here. The 1 also has to be here. Because anytime you have 3 digits, I guess this is another shortcut. Anytime you have 3 digits that add up to a digit, 3 unique digits that add up to another digit that's not 9, that's less than 9, it always has to contain a 1, right? Because 6 must be 1 plus 2 plus 3, 7 must be 1 plus 2 plus 4, and 8 must be 1 plus 2 plus 5, or 1 plus 3 plus 4. Therefore, this contains a 1. This contains a 1. We know this contains a 1. Okay. So therefore, okay, in box 6, where is a 9? This 9 gets eliminated by this 9. This 16 cannot have a 9 because of the possibilities that we had. We know this is 1, 2, 3, or 1, 2, or 4. This cannot have 3, 4, and 9. Therefore, the 9 has to be here, which means this has to be 8. Because the 9 is eliminated. So this is 9, and therefore this cannot be 8 here. The 8 still could be here, but we don't know. One of these two is 9. So this is 13 without a 1. What are the possibilities here? It cannot have an 8 either. Can it be 9? If you try to make it 2 plus 3 plus 9, that's 14. So this cannot contain a 9 either. Therefore, this is not 9. This does not contain a 9. This cannot contain 9. That does not contain 9. The only possibility in box 2 with a 9 is here. So this can't be 9, which eliminates that 9, which means that has to be the 9 in box 8. This can't be 9, so the 9 has to be in one of these two cells. Because the diagonal is eliminated here. This can't be 9, this can't be 9, and again, this can't be 9. Okay. Fine, I'll use the normal conventions. I don't like using the corner stuff, but anyways. Okay, so the 9 has to be in one of these two squares, and these two cells add up to 9, so this cannot be 9 because it would add up to have to have a 0, which obviously doesn't work in normal Sudoku. So that can't be 9, therefore this is the only possibility for 9. So that's the 9, which eliminates that 9 there. 15. Now, this could actually be... Okay, so 8 has to be one of these two, which means 8 is one of these three. So this cannot contain an 8 either. So it's at most 7 that you can have. I guess you could have 7. Okay. This adds up to 9. So it cannot be 1 and 8 because the 8 has to be here. It could be 2 and 7. It could be 3 and 6. Or it could be 4 and 5. These two add up to 10. So 1, 9 does not work. 2, 8 does work. But the 8 can't be here, so the 2 can't be here. 3 and 7 works, and 4 and 6 works. Right. Let's see. 8 cannot be here. 9 is either here or here. 8 can be any of these on this line. Okay, this could be 9, right? It could be 2, 4, and 9. Oh, wait, no, it cannot be 2, 4, and 9. Can the 9 ever be here? We know there's no 1. It cannot be 2. For this to have a 9, it would have to be 2 and 4 at least. But if it's 1, 2, if this is 2, 4, 9, this would have to be 1, 3, and 5. But that adds up to 9, and that's not possible. So this could never also have a 9. So the 9 cannot be here, the 9 cannot be here, therefore this is the 9, which means this can't be 9. So this has to be the 9, which eliminates this 9 on the diagonal, which means this is a 9. This can't be 9. This is a 9. So this can't be 9 either, so this is the 9. There is no 9 here. Okay. So we have all the 9s taken care of. The 8s are still a little questionable. So then this has to be, okay, so we can remove the blue because we have all the 9s. 8s. Can this be 8? If it's 8, it has to be with 15. That would add up to 7. So it would be 2 and 5 or 3 and 4. And that works fine as long as that's 8. But it doesn't have to be an 8 here. Okay. Where is green on this line? The green could be here, 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 or here. There's a lot of possibilities. 13. What does this mean? So this, I think, means you have to have a 6 or 7, right? For it to add up to 13. Yeah, because if you don't have a 6 or 7, it would be only 3, 4, and 5, and that only adds up to 12. So you need a 6 or 7, but you can only have one of 6 or 7. Therefore, one of 6 or 7 is here, right? Because a 6 or 7 cannot be here. So one of 6 or 7 is here, one of 6 or 7 is here. So this has to be an 8 with a 6 or 7. And therefore, there's another 6 or 7 here without a 1. So this is 2 through 7. We don't know about these. Okay. So if this was, again, so it's 16, right? If this was 3, 5, and 8, this would be 6, 7, 6, 7. If this is 3, 6, 7, this is 5 and 8. If this is 4, 5, 7, this is 6 and 8. I don't know if that tells us anything. This could be 1, 5, 6, 2, 4, 6, or 3, 4, 5. This cannot be 2 and 9 anymore, so this could be 3 and 8, 4, 7, or 5, 6, because these two add up to 11. Orange and red cannot be on this diagonal. Oh, that is a good point. If this is 6, this would have to be 1, 2, and 3, right? So that would add up to 6. You have 6 plus 13, which is 19. And then these 3 cells would have to be... I don't think that works. So these 3 cells add up to 13. These 3 cells add up to, at most, 8. Okay, yeah, that's it. So these 3 cells add up to 13. These 3 cells add up to at most 8, which means these 6 cells add up to at most 21. And that's the maximum for those 6 cells. That would force this minimum to be 24, which is the maximum possibility for those 3 cells. So this has to be 7, 8, 9, which means this has to be 8. Right? Because again, this 8 plus 13 is 21. That's the maximum these 6 cells can be. Yet that's also the minimum you can ever have for 6 cells. So therefore, that has to be 20. It has to add up correctly. So this has to be 13 plus 8. Therefore, this is 8. So this can't be 8, which means this cannot be 5. And this has to be a 1 or a 2. Interesting. Okay, so this is 7 or 8. This is 8. This is 7 or 8. This is 7 or 8. So this cannot contain a 7 or 8 in column 6. So there's no 9 already. So this is 1 through 6. This is also 1 through 6. Because we know this is a 7, 8, 7, 8 pair, which eliminates any other 7 and 8s in that column. Now, okay, so we have both 6 and 7s on this diagonal. So 6 and 7 are eliminated also on this diagonal. So we have 1, 2, 3, 4, 5, and 8, possibly, on this diagonal. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. This could be 1, 2, 3, 4, 5, 8. So the 8's either here or it's here. So on this diagonal, since it's this unique set, the 8 has to be either here or here, right? Because this can't be 8 because of these two, this 7, 8 pair. This can't be 8 because it sees this. This can't be 8 because it sees this. Therefore, this has to be 8, or that's 8. And since either one of those are 8, they both see this cell, which means this must be the 7. So this must be 8, this must be 7, this must be 8. This can no longer be 7, which means this can't be 4, because 4 and 7 go together to add to 11. So 7 cannot be here. 7 cannot be here. Therefore, the 7 in box 5 has to be one of those two cells. This can't be 7 because of this. So this 7 eliminates that 7, which means this can't be 2. This has to be 6 with something. So it's either 6 with 2, 5, or 3, 4. So the 6 is here, which means 6 can't be here, which means 3 can't be here. This is 1 through 7, but no 6. This is 1 through 7, but no 6. Okay, this can't be 7, so this can't be 3, because these two must add up to 10. Where can the 7 be? The 7 cannot be here. The 7 could be here, or the 7's here. So the 7 is one of these two on the outsides for this line specifically. That diagonal. We can remove the green. Okay. So if this is 6, oh, that's interesting. If this digit is 6, that means these 3 digits add up to 6, and these 3 digits add up to 15. Which, again, if that's the case, then this would be add up to 21. Which would mean these 3 digits in box 4 have to add up to 24, which would make this an 8 and this a 7. So if that's the case, if this is a 6. Oh, even if this is 7, that's interesting. So if this is 7, can this ever be 8? No, right? Because this could only be 3, 4, and 8, possibly, because we know 1 and 2 are already taken into account. But the problem is 1 of 3 or 4 is here. So this can never be 3, 4, 8. Therefore, we know this is always 8. So that's 8. Because this can't be 8, this can't be 8, this can't be 8, and that can't be 8. Therefore, that's the only possibility for 8 in box 4. So this can't be 8, which means this can't be 3. So since this 8 eliminates that possibility for 8, on this positive diagonal, the 8 can only be here. So this is 8. Therefore, this cannot be 8. And that works. So 8 has to be one of these two. It can't be that one, obviously. So therefore, this has to be 8. And since these two add up to 11, this has to be 3. So there's no 3 here, no 3 here, no 3 here, which eliminates 6 as a possibility there. This can't be 8, so this can't be 2 anymore. This cannot contain a 3. So this is either 1, 3, 5 or 2, 3, 4. So the 6 is not available here. So therefore the 6 is here, which eliminates the 6 from there, which eliminates the 4 from there. So we got 3 and 8 here. If this is 6, this has to be 7. So the 7 in column 3 has to be one of those two cells. So the rest cannot be our 1 through 6. This can't be 3, obviously. This is 1 through 6. And the 7 could be one of those two. Interesting. So if this is 7, though, this cannot be 6. Right? If this is 7, that means this adds up to 7. This adds up to... Wait, no, it has to be 6. Right. If this is 6, these 3 add up to 6, and then you have 15. So that's 21. So these 3 cells must add up to 24, therefore that's a 7. If this is 7, these 3 cells must add up to 7. These add up to 15. That's 22. So these 3 cells, from just subtracting out 22 from 45, must be 23. Therefore, this has to be a 6 in that case. So this is a 6-7 combination. This has to be 6 and 7 pair, which means this can't be 6. There can't be a 6 or a 7 anywhere else in the row. So this can't be 6, this can't be 6. Therefore, we know 6 and 7 both have to be here, which means 6 and 7 cannot be here. So this is 1, 2, 3, 4, 5. This has a 6 or 7, so this is 1, 2, 4, 5, 6, and 7. So we know this one's the orange one because it's opposite the red. The red has to be here because there's no other place. Therefore, the red has to be in one of these spots. The orange is one of these two. So that means the orange cannot be here, the orange cannot be here. The orange has to be one of these four. The red has to be here. Okay, so 5 always has to be here because there's no other place for 5. Therefore, this cannot have a 5 here, cannot be 5 here, which means that can't be 4, so this can't be 5 either. And this has 3 and 4, or 6 and 7. We don't know which. Okay. This has to have a 6. The 7 has to be one of these two. Or one of these 3, I should say. So we have 1, 2, and we have an 8. 1, 2, 4, 5, 6, 7, 8. This is 1, 2, 4, 5, 6, 7, 8. Right? No 8. Okay, so this can't be 8. Oh, because of this diagonal. So since this can't be 8, this can't be 8, this can't be 8, this is the only possibility for 8. So this is 8. Which means this cannot be 8. Which means 8 must be here. And then these two add up to 8 also. So the only possibility for that is 3 and 5. So this cannot be 3 or 5. This has to be a 6, 7, 6, 7 pair. Because this is 3, this can't be 3. Therefore, this is 1, 2, and 4. Therefore, this must be 7. So this is 7, this is 6, this is 7. This cannot be 7 here because, oops. So therefore, this must be 1, 2, and 3. 2, 3, which means this is 4, 5, 6, and a 4, 6, no 6 here. This can't be 3 because of this 3. So this can't be one, no 3 here because the 3 has to be here. This must be the 6 because of this 7. So this is 7. This 7 eliminates that possibility for 7, so this has to be the 7. There is no 6 here. Or red is 6, so this can no longer be red. This can't be 7 anymore because of this 7. So this has to be 4, and then this must be 6 to add up to 10. Therefore, this has to be the 7. Because 7 can no longer be here, here, or here. So this is 7. Which means this cannot be 7. This can't be 4. This cannot be 4. This cannot be 4 because of this 4. These two can't be 4 because of that 4. This can't be 4. Since this can't be 4, this has to be 1, 5, and 6. So this has to be 2. Which means this is 2, 3, 4. So no 1 or 5. This can't be 2. None of these could be 2 because the 2's here. Obviously, these can't be orange anymore. This can't be 2 because of that 2, so this has to be the 2. This becomes a 1, 3 pair, which means there's no 1 or 2 on column 4. So this is 4 and 5. So if this were the 4, this would have to be 5, but that would eliminate all possibilities for this cell. So this cannot be 4 and 5. Therefore, this must be 2 and 7. No 2. No 2, no 2. This can't, oops, no 2. This can't be 7. This can't be 2. This can't be 2. This can't be 7 anymore, so this is no longer the orange. Therefore, this is orange and 7. So this has to be 7. I don't know what I did. Clicked on the wrong button. This is a 7. This can no longer be 4, so this is 1 or 3. This is 1 or 3, because this has to be 4, 5, 6. So we'll remove that. Coloring. We can remove this orange too, because we have 7 now. This is 2, 3, 4. We know the 6 is here. This is 1, 5, 6. This is 1, 2, 4. So this is added up. So this has to be 4, 5, and 6. This cannot be 3 or 5. This cannot be 3 or 5. So this is 1, 2, or 4. The 4 then has to be one of these two. So this cannot be 4. We have 1, 2, 3, 5. So this can't be 2. So this is also 1, 2, 3, 5. And we have 1, 2, 3, 5, 6 here. 4, 5, 6. Yeah. So this can't be 6. This can't be 2. Because of their respective cells. Eliminate. Okay. So now we just have to eliminate stuff. In row 2, where is the 6? It can't be any of these. Oh, wait, no. This can't be 6, but 6 could be... Okay, 6 cannot be here. In box 3, where is the 6? It can't be here because of this 6. Can't be here because that's 6. It can't be either of those because that says 6. And it can't be that. So therefore, this is the 6 here. So since this, not all of them, just this one, 6, since that's 6, this can't be 6, which forces this to be 6. So that can't be 6, this can't be 6. The 6 then is one of these two, which doesn't tell us anything, unfortunately. So the 6 is one of those 3, the 6 is one of those 2, the 6 is one of those 3. What about 2? Oh, this is odd. So this cannot be 2 or 4. So let's go back to the rules. On the main diagonals, it's regular main diagonals. That's a set. Digits on an arrow. Okay, so arrows are done. Cages are done. Digits in a marked diagonal sum to the killer clue. So we've done all the little killer clues. Digit in gray must be odd. So this is odd. Okay, where's 4 on this diagonal? Right? It cannot be any of these 3, and it cannot be any of these 3. Therefore, the 4 must be on this diagonal. Therefore, that eliminates 4 from the rest of box 5. Okay. We know the 4 is here. We know the 4 is either here or here. The 4 could be any of these 3. So there's 1 of 4 or 5 in one of these two cells. Right? I don't know if that tells us anything, to be blunt. What about the 1s and 2s? Can we get anything information from that? Let's make this orange. This can't be 1 or 2. So the orange has to be one of those 2. The orange must be one of those 4. Ah, where is the 2 in this diagonal? The 2 cannot be any of these 3. It cannot be either of these 2. It can't be one of those 2. So the 2 has to be either here or here. Which means that they both see this cell, so that cannot be a 2. So this has to be the 1. And from Sudoku, we know that's 4 and 2. This has to be 3. This has to be 1. So this can no longer be 1. This can no longer be 2. This can't be 1 or 3. This can't be 1 or 3. So the 2 has to be one of those 2. This can't be 4 anymore. So in box 5, then, the only possibility for 4 has to be here. So this is 4. This can't be 1. This can't be 1. So we have a 3-5, 3-5 pair on this diagonal, which means 3 and 5 cannot be on that diagonal anymore. So that can't be 5. This can't be 5. So this is a 2, which eliminates the 2 here. This two can't, or sorry, these 2 can't be 2 because of this 2. Therefore, the possibility for 2 can only be here now in box 3. So this is 2. The 4 can only be here in box 3. This is 1. Now we just do normal Sudoku. So this has to be the 1. This can't be 1. This cannot be 4 anymore. So this cannot be 3, 4, 6. So this has to be 1, 3, 4 here. So this cannot be 2 or 5. This can't be 4. Well, you know this is 1, 3, 4, 1, 3, 4, which eliminates the 4 in row 3. So this is a 5. This is a 4. This has to be 2, 5, and 6. So this is 2, 5, 6, which means that can't be 5. This is 5 because the 4 got eliminated from here. This is 4 because of normal Sudoku. This can't be 4, so this has to be the 4 in this 2, 3, 4 set. This can no longer be 4 because of that 4, so this is a 5. That must be this 4 and this 6. So this can no longer be 4, so this is 4. This can't be 6, so there's only 6 possible in box 5. Has to be there. This can't be 6. This has to be 3 then, because this 5 eliminates that 5. So this is 3. This is 2 then. This is 5. So this can't be 6. This can't be 3 anymore, so that's a 1. This is a 5. This is a 3. This is a 1, which forces this to be 3. That 5, that 1, that 3, 2, 3. So this can't be 2. This is 6, 5, and 2. This is 3. This is 1. This is 3. That's 3 in the corner. Celebrating. This is 5. This is 5. This is 1. And this is a 6 all through Sudoku. And that took actually a decent amount of time. But I don't think it was necessarily like average level difficulty. It was pretty straightforward. And you just need to know like basic math and killer cages. Actually, it's just basic math, really, to just be able to solve this. It took a little longer, but yeah, easy level difficulty, definitely, which is which is normal, I guess. But recently I've had a lot harder easy level difficulty puzzles, so it's nice having an actual easy level difficulty puzzle here. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.